Good afternoon, Dr. G. Vijay Kumar, Professor, Department of Agriculture Engineering, Sri Shanmuga College of Engineering and Technology. So today we have a topic on pumps and its types, especially the positive displacement pump. First of all, the pump is defined as it is a hydraulic device to lift the water or any liquid from lower elevation to higher elevation. So that is the definition for pump. And here the energy are converted as electrical energy is converted into mechanical energy, and the mechanical energy is converted into hydraulic energy. So by using electrical energy we can convert the motor into mechanical energy, so that the mechanical energy is creating the pressure drops, and it creates the lifting of water from lower elevation. That is what hydraulic energy. So the energy conversion in pump occurs, electrical energy is converted into mechanical energy, mechanical energy is converted into hydraulic energy. And type of pumps are categorized based on two categories. One is by positive displacement pumps, and the second one is the variable displacement pump. Positive displacement pumps provides the discharge with a constant discharge rate, even though the head is varies. The head is nothing but the suction head, and the delivery head includes the total head. The total head is the where the water table is available. That is the vertical height between the delivery pipe, center of the delivery pipe, to the suction water table height. Based on that, the discharge rate is constant. That is called a positive displacement pump. But the variable displacement pump provides the discharge not a constant level when it increases or decreases with respect to the total head is increases or decreases, or there is a changes. So the positive displacement pumps are classified into two types. One is called reciprocating pump and rotary pumps. Then variable displacement pumps is centrifugal pump, turbine pumps. In turbine pumps we have different type of pumps are available. One is deep well turbine pump, submersible pump, propeller pump, jet pump, and the airlift pumps. So now we are going to discuss about the positive displacement pumps, that is reciprocating pump and rotary pumps. So what is the positive displacement pumps? Or in a positive displacement pump, the fluid is physically displaced by mechanical devices such as plunger, piston, gears, cams, or screws, etc. In this type of pump, the vacuum is created in a chamber by mechanical means, and then water is drawn in this chamber. The volume of water thus drawn in the chamber is then shifted or replaced mechanically out of the chamber. So by using this chamber, the water discharging water is constant. That is what positive displacement pumps I already said. Okay, in the suction, end of the suction, we can provide the chamber. That water or any liquid is sucked or lifted from the lower elevation, that will be occupied in the chamber, so that the constant discharge rate will be provided by the positive displacement pumps. So this is the schematic diagram of the reciprocating pump. So it consists of the piston. This is called a piston, and the cylinder. The cylinder is the outer cover of the piston. The piston is available inside the cylinder, so that the piston is moving forward and backward by the connecting rod with a reciprocal action. So when it's moving forward to backward, the piston and the connecting rod will rotate 180 degree, and also it's provides the half revolution, and again the backward to forward, again it's also rotates another 180 degrees, so that it's complete one revolution per two stroke. So that when during the backward to backward from forward direction, the suction is takes place. So from the suction pipe, the water is from the water table, and when it's moving from backward to forward direction, this sucked fluids will be discharged and delivered into the delivery pipe, and finally it's discharged. So that this done by reciprocal action. This is called reciprocating pump. So it is classified into two reciprocating type of pumps. One is called a single acting reciprocating pump and a double acting reciprocating pump. So the first one shows the single acting reciprocating pump. Single acting means there are only one direction of inlet and outlet. That means suction and delivery. So as it shows animated like this, the inlet when it's takes from the lower elevation and it's discharging the outlet in the upper elevation in only one action. But in the case of double action, it provides two inlet and two discharge. So likewise, we can find out the determine the discharge rate of the single and double acting reciprocating pump as given in the formula like LAN divided by 60 for single acting, but for the double acting 2 LAN. For two action we are multiplying the just we are multiplying 2, so that is why 2 LAN by 60 is multiplied. So L is the length of the stroke, A is the coverage area, cross-sectional area, and N is the number of revolution divided by 60. So that this pump discharge can be calculated for single and double action reciprocating pump. The next last one is called rotary pumps. So this reciprocal motion is replaced by rotary motion here in this type of rotary pump. So two gear pumps are attached here like in the opposite direction like in the picture. It's all two will rotate in the opposite direction as per the direction of motion indicated here, so that when it is operating in opposite direction, actually the left side indicates the suction pipe and the right side indicates the delivery pipe, or that means the discharge pipe. When it rotates opposite direction, it creates the vacuum and the pressure drops, so that the suction in the suction the water or any liquids can be sucked through this suction pipe and it's discharged in the discharge pipe. This is what how the rotary pumps are working under the principle of this rotary reciprocal rotary motion. So it is achieved by the two cams or gears, that is as mentioned like that in the picture. They rotate in opposite direction. The water enters through the suction pipe and it's trapped between cams or teeth of gears. It is then thrown with force into the discharge pipe. Useful for moderate head and a small discharge not greater than 40 lps. So this type of pumps are used mainly in the where we are having lower discharge rate like 40 lps, lesser than 40 lps. Lps means liters per second. For 1 second the discharge rate will be 40 liters, so that is the meaning. So where the lesser than 40 lps, this type of gear pumps or rotary pumps are used.